All right, we're talking about polynomials, and we're starting on page 124. It is starting up chapter 5, and really this topic right here is dealing a lot with what algebra is all about. And what was actually cool is, you know what we're talking about today in Algebra 1 Honors? Polynomials. And I did not have that planned. They're on chapter 7-1, and you're on 5-1, and they're the same topic. And what I'm actually having them do, which you can look forward to next year, is I'm not teaching it today. They are teaching it today. So they're going to be able to talk to their peers and teach it like they do up here. I haven't told them that. I'm going to record it because I want them to see how they did, and I need to be able to see and grade them on how they teach something. But do you have to teach it today, guys? No. And some of you are like, please, no. No, you don't have to teach it today. Do you have to know it today? Yes. Will you have to teach it in about a year's time? Probably, yes. Not everyone will teach it, but probably a lot of you will. Okay, so polynomial, that is a strange word, but before I deal with polynomial, I need to deal with what we call a monomial. Can you guys say that with me? Monomial. That's monomial. Okay, do you guys notice the prefixes on these words? I got mono and poly. Anyone know what those mean? Yep.
Mono means one.
Mono means one. All right. Monotone, monochrome. Those are one color, one tone. And then poly. What does that mean? Multiple or more than one. Yep. So I have one and many. Before I can understand the many, I need to understand the one. So did you guys write this definition already? Okay, that can be kind of confusing because like, what? Okay, here I'm going to break it down to hopefully simple parts. All right, a monomial is a number. Okay, it's a number. Have you guys dealt with numbers before? Yes. So have you dealt with monomials before? Yes. So you've already dealt with this topic, but you haven't really looked at it this way, and we're going to hopefully get that down today. It's also, or it can also be a variable. So have you dealt with variables before? Yes. So have you dealt with monomials? Yes. And then the third thing it could be is I'm going to underline a product. Okay? It could be a number, a variable, or a product. Have you dealt with products before? What is a product? Who can tell me what a product is? What are we talking about with products? I know Alex knows. Okay, Drew, I see that hand. What's a product referring to?
Multiplication.
Yeah, it's multiplication. You're dealing with something being multiplied. All right, what's being multiplied? A number and one or more variables. So have you dealt with multiplying of a number and one or more variables? Yes. So have you dealt with monomials? Yes. Okay, so here are some examples. You can write these down underneath the definition so you have it for yourself. Here's one, the number 19. Is that a monomial? Yes, because it is a number. Okay, so that's, I hope, very straightforward. Okay, here's another one. It's the letter M, or the variable M. Is that a monomial? Why is it a monomial, Sophie? It's a variable, so it's either a number or a variable. So far we have those two examples. And then we also have, this right here, 7a squared. Is that a monomial?
Yes.
Henry says yes. Why, Henry?
Because it's a product.
It's a product of a number and one or more variables. And you can think of this as like a times a. Please remember that. A times a is a squared. Okay, so that's a product of a number and variables, or you can just think of that as one variable, so 7 times a squared. Okay, then we also have 13xy. Is that a monomial?
Yes.
Yes, why is it a monomial, Darius?
Because it's a number and a variable.
There's more to it. I need more of that. It's not just a number or variable, it's a number or variable being multiplied. Yep, they're being multiplied, so that's a monomial. Okay, another one here. 1/4 a, b, c to the 10th. Is that a monomial?
Sadly. Sadly, yeah.
Sadly, Philip, but why is it a monomial? I know this guy right here knows. Okay, Hudson, what do you think?
It has a number of variable and product.
Okay, good. It's a product of a number of variables. Wait, 1/4 is not a number? Yeah, it is. It's a number. All right. So it's a number, and these 3 variables, or these 12 variables being multiplied, it's a monomial. Okay, you guys good on looking at monomials? You're like, so what are not monomials? Well, that's the question we're going to answer here. On this board, I'm going to write some examples, and I want you guys to think it through. Okay, right here. X plus y, is that a monomial? X plus y, is that a monomial? Yes or no? Okay, is this just a number? Nope. Is it just a variable? Nope. Is it a product? No, it is a sum. This is not a monomial. X plus y is not a monomial. Okay? X over y, or x divided by y, is that a monomial? Okay, why not, William?
It's a quotient, not a product.
Okay, yeah, it's a quotient. They're being divided. It is not a product. It is not a monomial. Ooh. The return of the negative exponents.
Yes.
Yes or no? Let's see here. All right. Think it through. 50-50. Woo. What's the answer?
Yes.
Okay. The answer is no, not a monomial. Why not?
Because negative is less than 1. So you need 1 or more variables.
Okay, I think I see, like, that's not a variable, or sorry, it's smaller than a 0, or smaller than a positive. It's not a monomial, and this is why. And this is review, and I don't expect you to know it, but maybe some of you are going to get it. Do you guys remember how I can rewrite a to the negative second? Do you guys remember this? This is months ago. Think of the word reciprocal. This right here can be rewritten as 3 over a to the second. Right? What's that? A quotient. Is that a monomial? No. So what about this? No, not a monomial. So basically, if you have negative exponents, not a monomial. Do you understand me? I'm going to say that again. If it has negative exponents, not a monomial. Hudson, what did I say?
If it has exponents, it's a monomial.
If it has negative exponents, not a monomial. Okay, good. Yeah, just be careful whatever's going on there. What about 2 over y to the 3rd power? Ooh, positive exponent. Monomial or not?
No.
Not a monomial. And do you know why? Because of the y? And the quotient? Actually, I can rewrite this as 2y to the negative 3rd. There's no quotient there. But what do we have? Negative exponent. Okay, guys, I'm not saying you can't have a negative number. You can't have a negative exponent. Good, good. All right, so 2 reasons why that's not. And this one. Yes or no? Monomial or not? No. Not? Wait. Oh, sorry. I need to rewrite it. 3m n to the negative 1st. And I can do actually just say 3/2 m n to... Oh, what do we have? Not a monomial. So these are not monomials. Do you guys get what a monomial is and what a monomial is not? Are you sure you get it? So I'm going to start quizzing some of you. Any questions? Yes, sir? Okay, all right. Here we go. All right. Up on the board here I have a few examples, and you're going to tell me yay or nay, yes or no, if it's a monomial or not. This is after. I'm going to do this part first. Okay, Jack, monomial?
Yes.
Why?
Because it's a variable.
It's a variable. Good. It is a monomial. It's a variable. Matthew, is that a monomial?
Yes.
Yes. Why?
Because it's a variable and a product.
Okay, it's a product of variables. Good. All right. Jackson, is that a monomial?
No.
Why not?
It's a quotient.
It's a quotient. But can I write it as negative 5t to the negative first?
Yes.
But
it's still quotient.
okay, so quotient and yeah, but what's wrong with that negative 1? Can I have that? To the negative first power? No, can't have that. So not a monomial right here. All right, Hagen, 3.125. Is that a monomial?
Yes.
That's not a variable. That's not a product, but what is it?
It's a number.
It's a number. It's a decimal number. Don't be afraid of those. Good job. Right here, Michelle, negative 12x cubed y squared. Is that a monomial? Why?
Because it's a product of numbers.
Good. Product of numbers and variables. Awesome. Josiah, 4 over m to the third. It's a quotient, but how can I rewrite it to not make it a quotient? Good. And wait, that's not a quotient anymore, but what is wrong with that? Negative exponent. Good. Here, Sam, M-N-O-P. Q-R. Oh, sorry. I'm just used to saying the ABCs. Go ahead.
Yes.
M-N-O-P.
Maybe no. Yes. I guess because
Why?
it's a product of variables.
It's product of variables. It is. Good job. And down here, Anna Grace, 2APQ to the negative first.
No. Because it has a negative exponent.
Negative exponent. It is a no. You guys okay with those? Okay, now it's time for a real quiz down. Everyone will do these 4 problems. So that's why I have 1 through 4. And they are found on page 125. At the very bottom it says try these. You guys see where it says try these again? We're back to this. Numbers 1 through 4, tell whether the expression is a monomial. If it is not a monomial, explain why. You just have to do that verbally. So just say yes or no, and then I'll ask you why or why not. It is a monomial. Sorry. Hard book. Page 125. So on the no's, and really even on the yeses, you should be able to say why or why not. It's a monomial. And I'm going to pick 4 people who haven't said a thing in this class to me one-on-one. Did you? Okay. Okay, the first person who has not said a thing to me this class period, personally, one-on-one. On page 125, number 1, is it a yes or no? Brad.
Yes, because it's a number.
Yes, it's a number, but it's negative. I thought you can't have negative numbers. You can't have negative exponents. Very good. Yeah, negative numbers are okay. It's a number. The other person hasn't said a thing to me. A thing. Not one thing. Eva. Number 2.
I said no because it's not a quotient.
Let's say that again. Okay, you said no, and why not?
Or a product.
There you go. But isn't 8 and c squared being multiplied?
It is.
But what else is in there that makes it not a monomial? You said it correctly, but see if you can point it out. There's a subtraction. So number 2, not a monomial. No. They have subtraction going on. That is not a monomial. Okay, and then number 3, Natalie, what is the answer number 3? Is that a monomial or not?
It's not.
Why not?
Because there's a exponent.
Say it again.
Because there's a negative exponent.
Where?
Well, you can rewrite it to...
Okay, good. Yep, if you rewrote it, you would get that v to the negative 3. All right, and then number 4, Mary.
No.
You said, sorry, what?
No.
No? Okay, why not?
A quotient. So negative 1/9.
Okay, that's where I wanted to see if you guys, how do you think through that? Okay, but is negative 1/9 a number? Yes. So we're going to call that a monomial. If you had a number over a variable, not a monomial. So that's a good, I'm glad we brought that up. So do you guys remember, where was it? Like right here, is that a monomial? No, because I have a number over a variable. Is that a monomial? No, because it's a number over a variable. But what happens if you have a number over a number? Can that be part of a monomial? Yeah, so I'm glad we brought that up. Okay, now it's time to talk about polynomials. Polynomials. So what have we been talking about so far? Monomials. Now we're going to talk about polynomials. Don't say that too loudly because you might spit at someone. Trust me, I know. Okay. And once you write that definition, do you guys notice the use of the word or in these definitions? I use the word or 3 times at least now altogether. Well, actually, no, 4 times altogether. Not in this one, but with the other one included. Or. Why or? That's a great question. I'll answer that in just a bit. Write down that definition, and then we'll see why it's using those words and why I don't really like this definition. I don't like it. I'm not a fan of it. It's awkward. Okay. What does the word or mean?
I mean, in this definition, there's also other things that is a polynomial. So it's like almost we're using it as and pretty much.
I think right here maybe you might think that. I would be maybe okay with that, but and or are not the same. They're not the same thing. And here's what I mean by that. Matthew and Drew. I'm going to use you two right now. Okay, today I have a test. And Matthew or Drew will take the test today. What does that mean?
Either one of them.
Either one will take the test, right? One or the other. The next example, Matthew and Drew will take it today. And what does that mean? Both of them will take it, right? So are the words or and the exact same thing? No. So let's look at it here. I got or all over the place. Okay. A polynomial, first of all, is a monomial. So all those monomials we looked at, what are they also known as? Polynomials or polynomials, however you want to say it that regard. Okay, so it can be a monomial. Or it can be the sum, and then I have this weird thing here. The sum or the difference. How in the world... Okay. Why didn't I just say the sum or the difference? Why did I say the sum and or the difference?
Sometimes it could be included.
Okay, here's what... Okay, anyway, it could be included possibly in them.
Well, they could be together or separated.
They're together separated. I'm gonna go even deeper than that. All subtraction problems could be rewritten as addition problem. So I could have just said is a monomial or the sum of 2 or more monomials. I could have just said it that way. Because what can I rewrite any difference as? A sum. I can make any subtraction problem into n. Are you guys doing all right? You guys doing okay? You guys look a little down. Is it warm in here? Is it warm? Is it because we're so close to Christmas break and I haven't given you my present yet? Is that why? Come on, you don't ruin it for people. You don't open people's gifts up before Christmas and tell it.
You just go downstairs and get a board and all of your siblings gifts and just come up the stairs or something. That'd be fun.
I'm going to talk to your brother about that one. All right, anyway. See how fun he thinks that is. All right. A polynomial is a monomial, or the sum of two or more monomials. Okay, so let me give you some examples here, so you guys are at least get a feel for it. Okay, write that down, please, because I'm going to point out some things. Okay, this is not a monomial. Why is this not a monomial? There's subtraction going on. So it's not a monomial. So it is a polynomial, but not because it's a monomial. Like, what? Okay, let's look at it right here. X squared. If I just had x squared, if I just had that underlined part, would that be a monomial?
Yes.
Yep, x squared would be a monomial, right? If I just had negative 49, would that be a monomial?
No.
Yes, negative 49, monomial. But what's going on between these two right here?
Subtraction.
Addition.
Adding and
Okay, I'm going to take subtraction, but what do I really want you to think of it as?
Addition.
Addition. Are these two monomials being added?
correct.
So they are known. This whole thing together is called a polynomial. It's two monomials being added together. Okay, and I'll keep giving you some more examples because some of you are looking at me or thinking, yeah. Wait, what about you're still back at the Christmas presents. You haven't lost that yet, but let's keep going here. Okay, let's give you a tough one. Okay, is this whole thing a monomial? No, not a monomial. Why? Because there is a addition. Good, got that. Is that a monomial?
Yeah.
I get the M, I get the N, but that is not a number.
Square root.
Is the square root of 3 a number?
Yes.
Yes, it's a number that we don't always know right away, but it is a number. You put it in your calculator, it gives you a decimal number. So do we have a number times two variables? That's a monomial. Is that a monomial?
C.
What are these two monomials doing together? They are being
Adding.
added. So what do we call this whole thing? A polynomial. Okay. You guys see where I'm at there? You kind of get that? All right. Now I need you to do this for me. On page 125, do you guys see at the very top of the page it says examples? We did example 1 together. Example 1's done. We did that up on the board. But we are now on example number 2. And I just did A and B. Now we're going to do the rest of them together. C. Do you guys see what I'm talking about? Negative x, y to the 6z. Is that a polynomial? I'm just looking at that. Is that a polynomial?
Yes.
Wait, is it even a monomial?
Yes.
It is a monomial, right? Because it's just being multiplied. And it is a polynomial. D, I'm going to write this one up here. This one looks so bad. I think it's this, and if I change something, it's okay. All right, that's it. Is that a polynomial?
Yes.
All right, what's going on that makes it not a monomial? How about that? Addition, right? Right there. Not a monomial. Okay, what about that? Would that be a monomial? Would this right here be a monomial? Like this right here?
No.
No. So guess what? This is not a polynomial. It's not a polynomial, okay? These two are, that one is not. You would say not a polynomial. Ooh. You thought that one was tough. This might be slightly different from the way the book writes it, but oh well.
Yes.
Excuse me? Wait, don't make up words. Okay, is this a monomial? No, because you have not only one but two addition signs. Would this be a monomial?
Yes.
1/2 b, is that a monomial? Is this a monomial? Is that a monomial? What's happening with these three monomials? They're being added, so guess what they all together are considered? Polynomial. Okay, I think you guys get that, right? You guys understand that? there are three types of polynomials. We need to get these down. This is like the last major part. So I should say the last terms part that we're going to get. How many of you maybe don't like the word monomial? You don't like saying it? You don't like looking at it? Be honest. I don't care. It doesn't offend me. I didn't come with it. Wait, now I'm offended. There are a lot of you. Okay, no. I don't. I mean, it's just the term that you use. I wish there was a better way of saying monomial. Yeah, or now you're starting to come up with new things. No, I'm talking about something you've already dealt with that makes it easier for you to remember what a monomial is. And there is.
A variable.
It's a term. It's a term. Wait, Mr. A, why didn't you just say it was a term? Because this lesson is so much more fun when you don't say it until now. It is a term. Have you guys dealt with terms before? Yes, I have dealt with terms many times before, and you will continue to deal with them. So, have fun. Okay. Monomial means one term. Okay, one term. Binomial means
3, 2.
Two terms. Leave some space there because I need to write something else at the end. A trinomial means
3 terms.
3 terms. Look at that. But it's not just, we're not just saying 2 terms and 3 terms and all that. We actually mean 2 terms that are added. That are added. And you're like, what about subtracted? Same thing. And I'm going to put these little quotation marks. You guys know what those mean? That just means what I wrote up here that are added should be right down here, that are added. That does clarify a little bit because we're not just talking about, oh, this term and that term are binomials. No, when they're added together, they're a binomial. Okay, if you have one term, what do you call that? Monomial. If you have 2 terms that are being added, what do you call that? Binomial. 3 terms being added, trinomial. Do you guys get that? So have you looked at terms before? Mm-hmm. You have. Do you like terms?
No.
You do like terms. Oh man, this is 43. Goal number 43. You will love terms by the end of the year. You love them. You love them a lot. Okay. Let's look at this example right here. Oh, wait, sorry. Oops. How many terms does that have?
4.
Who can give me the first term? So just tell me, what is the first term? First term.
2x to the 5th.
Okay, 2x to the 5th power. Awesome. What's the second term? Matthew? Good. -3. Very nice. Third term. -2x to the 5th. Fourth term.
7x.
So it has. That's what I was thinking. Monomial, binomial, trinomial. Oh, good. Yeah. Sure. Quadrinomial. Time out. I don't like anything above 3. Look up there. Do you have any like terms?
So it's 7x minus -3.
These two are like terms. And what do we do with like terms? Combine them, and what do they give me in this case? 0. So I'm left with -3 plus 7x, which gives me a binomial. Binomial has 2 terms, right? So that's a binomial. You guys get that? Okay. Next. Ooh. Sorry. It's a fournomial. Oh, wait, 1, 2, 3, 4 terms. Any like terms?
3x4 and 5x4.
Which gives me?
8x4. Negative minus 4 plus 2x.
Are there any other like terms?
No.
This is not a monomial. It's not a binomial. It's a trinomial. Trinomial, as the British say. Trinomial is how they say it. I don't know. Although some of their words they do say, I like how they say it. But anyway, did you guys get that? Trinomial? Okay. I wish I were done with that, but some of you already know that's not where we end, is it?
It gets harder.
Uh-oh. Write that down first. And originally to the problem, you did not have that 1. How can I write the 1? Well, it's actually there. So I'm going to put it in for you guys. I heard it. Someone said it. Distributive property. You don't classify a polynomial unless it's been simplified. This has not been simplified. Work it with me, guys, because this gets tricky. I'm going to do 3a times each one of these terms. So I got this going on, that, and then finally that. Please listen carefully. What is 3a times negative 1a? Negative 3a to the second power. Okay, ready? Here it is, because some of you are like, 3 times negative 1. Sorry, that's a nice sound effect. Don't get me. Oh, barely missed it. All right, 3 times negative 1, negative 3. What's a times a? A to the second power. So that's how we get that second power. Oh, oops. I'm so sorry. Aren't these not like terms? Oh, no, wait. They are, aren't they? Wait. Are you allowed to multiply unlike terms? Good, I see that. Yep, I see that. Are you allowed to multiply unlike terms? Yes. Can you add unlike terms? Can you multiply unlike terms? All right, what's 3a times 7ab, Positive 21a squared b. Very nice. Yeah, we'll get to that. What's 3a times 2b? Plus 6ab. Yeah, and you tend to write it in alphabetical order, so like A, then B. You could say BA, but later on it's going to get confusing. You're writing them all in different order. Just do alphabetically. That helps you out. Are these like terms? Any other like terms here?
6ab and 2. No.
Okay, never mind.
Any other like terms?
No.
No. They like terms, remember guys, you need to remember this. Like terms have the same exact variables with the same exact exponents. Oh, wait, these have a squared, but do they both have b? Oh, these both have ab, but do they both have a squared? Okay. Oh, these two, wait, no. Okay, so you got to make sure they have the same variables, same exponents. Your turn. Yep. This is your exit ticket. You can leave once you get this right.
Okay. Do we have homework?
Yes. Someone unwrapped that present early.
You can take your time out.
Okay. While you're doing that, I'm going to pass back your tests. Who hasn't taken the test yet? Okay, so please don't talk about it because I have 2 people here, 1 over there. So don't just start blabbing about it and say, "Man, what'd you get for number 1?" And oh no. Yeah, don't say anything. Nothing.
Negative 6,443.
All right. Work that out as you get your test back. You're doing the distributive property twice, and look at each variable. Doesn't it have a number in front of it? Isn't there a number in front of p to the third power? Yes. It's 1 or negative 1 in that case. I don't know if that helps, but we'll see.
What's 91?
Jack. William. Sam. Sorry. Philip. Oh, that didn't work. Sorry, Jackson. Josiah. Hagen. Oh, sorry, Mary. Natalie.
What about the bonus?
Sorry?
What about the bonus?
Yeah, I'll explain the bonus. Some people got all, some people got part, some people got none. That's Andrew. Matthew. Alex. Hudson. Eva. Drew. Jackson. Oh, Michelle.
Let's go.
Sophie. Mary.
Do you need to bring these back?
Yeah, you need to get those signed and brought back tomorrow. No bonus points for that. You just do that. That's what you do.
Is 1p plus 1p
1p. Are you doing the multiplying or the adding? Like terms?
1p cubed plus 1p to the fourth, would that be 2p?
No. Are they like terms? These are two separate terms, and these are two separate terms.
So then, would negative 1p?
These two are like terms.
Okay.
Yeah. On the test, can you hold? Like, is it a specific question? Go ahead.
It was about the grade.
Listen up. On the test, you could get a maximum of 104%, which I think maybe one or two of you got, which is awesome.
What time? I got 1 point on the bonus.
Yeah. So on the bonus, you can. I think I gave up to 3 points. You either got 1 point, 3 points, or no points on the bonus because.
It has to be 104. That's mine.
Oh, sorry. This is the way I can't say. 2 people have to take. Signed, brought back by tomorrow.
What was the answer to the bonus?
I can't give it right now. 2 people haven't taken it.
What exponent do you give to variables without a
1. Okay. Let me go through this problem, and then I can answer specific questions. But I can't answer like what's the answer or how do you do this out loud. I might be able to do it in person. All right. Looking at this is tricky, guys. It's not easy, but that's why I gave it at the end. If some of you like to put 1s in front of your variables, there you go. You get your 1s. What's negative 1p cubed times 1p? Negative 1p to the 4th. What variable or what exponent does that have? As a 1. A lot of 1s, by the way, on this problem. What's negative 1p cubed times 1? Negative 1p cubed. Let's say the same. Do you guys? It's tough. Who would have known that having the number 1 so many times would make the problem even harder? Didn't it make it hard?
No.
It's not. Oh, okay. All right. It's cool. Sorry. All right. What's 1p squared times 1p? Positive 1p to the
cube?
Yep, to the 3rd cubed. What's 1p squared times 1p squared? Positive 1p to the 4th. So that's what I have now. I have 4 terms. 1, 2, 3, 4. Are there any like terms? These two are like, and these two are like. What do these two combine? They give me 0. What do these two? What am I left with?
0.
What kind of number is that? Monomial. It's a monomial. That was a monomial. It's the number 0. Sorry? Just to tell me it was 0. So this right here, this problem is another way of saying 0. 0 has many names, by the way.
Yeah.
And that one's its least common name. Okay. Yeah. It's called epicness. Wow. I don't know. Yeah, listen up. Hey, I need your attention real quick. This is a lot of problems, but guys, they're yes/no answers. Yes, it's a monomial. No, it's not a monomial.
We have to explain it to them.
No explanations, just yes or no. Only 38 to 42 need some work. Bye-bye, Swivel.